Now it's time to set up your system. And the first step to do that is placing the speakers on the right place. Especially if you have a small room, there is a huge room impact and the speaker placement is critical. Also, in most cases, you have limited options where to place the speakers. I have exactly the same situation for many years. But we will go through some general guidelines how to do that. I found one picture, and I would say this is the most important picture in our topic, how to place speakers. For example, I have a room about 3.5 or 4 meters wide and 5 meters, 6 meters long. And I even have a worst case scenario. I have doors here and doors here. So I have only option to put speaker in a corner and another speaker in a corner. What is not the best option? You should have some space from the wall. But anyway, even in such room, you can place and find a place where your music will be relatively precise. And here is the general guidelines. If you know the width of your room, and here is speaker placement. It is up to the center of the speaker. This is up to the center of the speaker. And another dimension is your listening distance. Actually, this listening distance is important. If you sit here, probably you will get a boomy bass. And there will not be good soundstage, so you should sit a little bit further. We will go through theory, you understand why. And also there's collisions with a low frequency or a bass, and when you sit in the right place, then the bass intensity will be correct according to the initial recording. And it is 1.25 of value of width. So you sit somehow in irregular place. I know that is difficult to do in your rooms in most cases. And here you have about 60-degree angle. But anyway, there is not much options. You can use even most expensive equipment and the best possible digital crossovers with a lot of tunings and filters and delays and other stuff of adjustments, and you still be not able to get a good audio reproduction if you will not place your speakers properly. Most probably this is consensus also with your spouse or some family members, who knows. But anyway, this is a critical component. Doesn't matter what type of equipment you will have. Only way and most important way is start with the right placement of equipment. And here is a good example how it is done in correct way. This is a large room, and in a large room you have by far better options to do that, and you will have by far better soundstage than in a small room. Unless the small room is not filled with furniture, some irregular type of furniture, books and bookshelves and other stuff. And this room has acoustic treatment, and it is done in the right way. Those half pipes or pipes, I don't know, they are dissipate reflections, and the best way to do it, because absorption is not a preferred way. And this room sounds awesome. Yeah, but in most cases we are not able to do that, and this is expensive. So we are not even thinking about the treated rooms. We should get best in non-treated rooms. Here is recommendation for home cinemas, how to set up them in a room. And you can see that you should sit close to the front wall and have a large space behind you. Then all reflected signals will be attenuated by distance square. And of course, going with a larger system, you are moving back to the back wall, but then you have additional speakers in between. And here is some very advanced system for multi-people usage. You have a number of woofers that dissipate that low frequencies, and then you have speakers in a ceilings and speakers on a wall and speakers in the front. Advanced system. This is THX certified way how to put your home cinema. And this is how it is recorded in studio. In studio, you're recording in this way. There are right angles, how you should place your home theater system for a proper cinema recording, and also your room should be treated. But this is some extreme setup, I would say. But some people are able to execute that. And now I put some absolute basic theory why so important is a room. Most of audiophiles are really concentrating on equipment, on amplifiers, on total harmonic distortions. But the room is the most important, and especially when we are talking about the speakers, amplitude, frequency characteristics. You can buy absolutely perfectly flat speakers, put in a room and get a shit out of it. And this is why. I'll look at the listening room sound components. And the first, we have direct sound. This is what we are getting from the speakers. It's very important. And then we have so-called first reflection sound. The first reflection sound reflects from the nearest walls, and they will come within 25 milliseconds. When they come within 25 milliseconds, they are considered as a one signal. As a direct and reflected, we are hearing as a one single signal. And then you have so-called reverberation. When your signal path is longer than 25 milliseconds, you are hearing it as echo. And those reverberations can come to your right ear from the right speaker, but it also could come to your left ear, and it is destroying your soundstage completely. Yeah, all those phase alignments are mismatched, and your soundstage is down. So, what is the definition? So, early reflections are those that arrive in general within the first 25 milliseconds following the arrival of the direct signal. If you sit h feet back from the speaker, it takes the direct about 7 milliseconds to arrive. The first early reflections is usually the floor bounce, which makes about 9.5 milliseconds to arrive from the speakers. It is 1.5 milliseconds delay from the direct signal. So, first reflections. We have a lot of first reflections added to our direct signal. It's important. It's not just the first reflection that matters to listener. It's all the energy reflections that fuses with the direct signal to form one composite direct signal. They distort the crystal clear information being delivered by the direct by overlying with a multitude of reflections that sounds just like the direct, except they are time delayed and come from a different directions. The careful time alignment of the speakers is obscured by the delays of the early reflection. Precision stereophonic effects are blurred over by all the different directions of the sound in early reflection group. And there is answer why you should not care too much about tweeter and mid-range alignment, because your room influence will be anyway much higher about that. Yeah, it makes some small impact, but it is not very important. And most of good budget speakers don't have the tweeter and mid-range precise time alignments. And also when you're working with 24 decibel crossovers, your overlay is really small, and normally you don't hear that. This is one reason why it's not important for any cost to have a digital crossover and have this delay adjustment. But many audiophiles complain and talk in a forum that it is super critical. In reality, not. One more thing. all those early reflections add up to a sound level that exceeds the strength of the direct signal about 7 decibels. 7 decibels. And when we're talking about amplifier amplitude frequency characteristics about 0.25 decibels, then we easily have a room about 7 decibels. For example, 20 reflections that are each on average 6 decibel lower than the direct signal delivers a late reflection package that is 7 decibels louder than the direct alone. And direct to the early reflection package, and you get a combined signal that is 8 decibel louder than the direct. So your all speaker tolerance is down. Your all speaker tolerance is down in a small room. What can you do? Of course, we can move closer to the speakers and get direct really high, and since those reflections has a longer distance and they are attenuating by distance square, then the soundstage improves a lot. You can test it. For example, you can stay somewhere here and stand, and your soundstage is so, and then you sit because you are away from the ceilings, and your soundstage improves a lot. Of course, in case you have high ceilings, then it's not work. But anyway, you can do a few experiments and find out how much soundstage improve when you just a little bit work with the locations. And what to do? The best way is dissipate, not even absorb, but it's difficult for different frequencies. But if you dissipate, this energy goes in all directions, and the direct really have a concentrate energy, and those are dissipate, and you have just some filled room, but you will get a very precise sound stage. And how to dissipate? With a regular furniture, with bookshelves, with sofas, with many things. What is allocated in a room, you have perfect listening room. Of course, you will have reflections from the floor and reflections from the ceilings, but that improvement makes a lot of sense. The late reflections, those after 25 milliseconds, marks the dynamic properties of the music. They should be absorbed or converted from hard distinct reflections into multiple low-level diffuse reflections. So all those furnitures and sofas and other regular furniture that you have in a room, those are good things, and they work for both treatments for your room. Let's assume that you have a clean Euro renovation room with aesthetic furnitures. Just one sofa and a TV set in the front. Then you get all possible collisions. And one of the worst thing is about 100 hertz. It's about 3 meters. And if your room is, let's say 4x7 or 3x7 or 5x8 or 5x10, then those 3 meters will have several collisions, and you have where direct and reflected waves are summing and cancelling. Depending on room size, you have several places or few. For example, if you sit here, you will have excessive bass. If you sit here, you will have no bass. And this is an extremely bad scenario, because it doesn't matter how much power you add, since reflected power will come back with also amplified power. They always cancel. Your neighbors will become crazier, but you still don't have a bass. If you sit somewhere here, you will have a perfect bass. If you sit somewhere here, you will have perfect bass. Those 100 hertz bass is important, and you have a very good bass. The same here. But if you sit on a wall, you will have excessive bass. And excessive bass, of course, you can attenuate in active speaker system, but also you will attenuate another frequencies about 300 hertz, where is a male low male vocal, and you will have a coloration. So it is better to sit with the neutral, this bass level. And at first drawing what you saw with the calculation, this somehow calculates at right place. The same picture as previous, and this point of collision you should avoid for any costs. For a maximum where the signal doubles, you can do something with sacrificing some collaboration. but with collision point, you should avoid it. There's no way that you get a good sound sitting here. In practice, it's not so bad because you also have some bass reflected from the ceilings, from the wall, and this is not a complete null, but this is most important signal. It is really strong. A little bit about the choice of crossovers. If you are really fanatic about tuning your room and tuning your speakers and tuning everything, then you can go for a good professional DSP. And I'm not recommending this one-chip small DSPs which are built in a budget professional amplifiers. Those one-chip solutions are not very good. And think as a holistic system. Most probably you have a streamer or a digital analog converter in a price range from hundreds to thousands, and you do one-time very expensive and precise digital to analog conversion. And then you are at a very high quality analog world. But when you go for a digital and the cheap digital solution, you are going back to digital, and then you're converting from digital to analog again 3 times for each channel. And the budget solutions don't have a good digital to analog converters. So digital to analog converters are expensive if you want to have in a good quality. There is a reason why some good device costs 500 euros or even 1,000 euros. You need all components good, and you need a good one. If you really want to go for a digital, my recommendation is to go for Direct PA2. This is a very good device. It has very good conversion. It has very good processing power inside. They are very precise digital to analog converters and analog to digital converters. They are excellent. But this is about a 500 euro solution. Then there is DBX 234 XS, and I have a good experience with that one, but you should buy in your region. They have either 220 volt mains or 110 volt mains. That is a conventional transformer in it, and it can't work from the both voltages. So this is such type of the limit. I see it's about 250 euros. Also, you can get the same differently branded units cheaper. This is branded, but I like this unit, and I will use it as example how to set up. This is absolutely minimalistic professional crossover. It has internally good components, really good components, and there is nothing extra, only that what you need, and you have large flexibilities to set up any system. Yeah, any system. If you want alternative to this one, I have a good experience with Behringer. This Behringer CX300. No, 3400 Super X Pro version 2. It's not in stock, but you can order. That Behringer has more. Let's see. Okay. Behringer has more options to quickly set up, because for a setup you need to mute some channels and adjust another channels. Somehow it's easier to set it. So if you like, you can buy a Behringer. It has built-in switching mode power supply, and it is operating for worldwide mains. That means from 100 volts to 250 volts in general. And it's a good device as well. I personally tested, and I like it. Yeah, no complaints at all. No complaints at all. And now in the BX three-way professional crossover, analog crossover, I will explain you basic principles how to tune your system without measurement equipment. First, in part 2, we already talked about what you need. You need a professional audio interface where outputs and headphone amplifiers are separated. You set up your volume at 80 decibels. It is louder than speech. It's some kind of music level that's really taking your soul, and you can do the long time listening. This is about 80 decibels. This is how in studio it is recorded. And you compare headphone signal with your room signal. And this is the best way to tune your system, because then all those room reflections also are included in your settings. I think it's a big advantage of active systems, because previously to somehow standardize when your crossover is fixed, you did crossover tuning on measurements in anachronic chamber, but when you put in a room, then you get different results in different places. And also those were not adjusted for your listening position. And here you can perfectly adjust it for your listening position. And this is a huge additional advantage to reproduction precision. And the right way is to tune your system based on your listening place, not as a flatness on 1 meter or other stuff. Because on a place where you listen, it should have maximum tolerance and maximum precision in reproduction. I'll look at some knobs on the back side, and you can see there are 2 knobs, and they should be in position when they are out. Sometimes even just taking equipment, you can push them in. And for a 3-way stereo, they should be out. This is configuration switches, and for a 2-way stereo, the left one is switched on and the right one is switched off. Here for 3-way stereo, you switch off both. And also when you switch both in, it's not valid. And for mono 4-way, you switch a right knob and the left one is out. So, but stereo, both out. For 3-way crossover, we have 2 crossing points. First between woofer and mid-range, and it's somewhere between 200 Hertz and 800 Hertz. So this is our scenario. And then we set the crossover frequencies for ×1. ×1, this knob should be out. And now this is a front panel, and what we have a gain input. We have gain input for both channels. And this gain regulates all levels, because here we have a first crossover point settings, here is a second crossover point settings, and here is a band level or band sensitivity regulations. We have different speakers, and those speakers have different sensitivities. Here we are matching the sonic balance. In our case, we will not invert signal. Invert signal you need for a measurement. But in our case, we don't use it. Just look that both of them are switched off. Yeah, all 3 should be switched off. When you switch it on, then LED lights. So first thing, what you start with the 1 speaker and set input level to 0, and do it for other channel as well. We will use it later on. So try to put this knob visually precise, that you can go back if some small kids' hands to change it. They like to play with the knobs, and this is only risk what you have, that they come and play with the knobs and everything will be mismatched. Second, you should choose your crossover frequency from woofer to mid-range. If you're close to the wall, it's not important, but if your speakers are away from the wall or in a middle of the big room, it makes sense. My recommendations is start with a baffle compensation point. And now let's understand what does it mean, this baffle compensation. Here is a good article from Elliott Sound Products about baffle step response. What does it mean? Let's drill down in the theory. The so-called baffle step is an increase in output from loudspeaker as the size of the baffle becomes significant in terms of the wavelengths of the sound for a range of frequencies. At low frequencies where the baffle, the panel of the loudspeaker is mounted on, is small compared to the wavelengths, as I mentioned at 100 Hz it's already 3.5 meters, the speaker is assumed to be operating with a spheric radial pattern. So speaker is a point. Speaker is a point radiating in a room. While this may be case should the speaker be situated up the tree in the middle of the field, it hardly qualifies as a true when some speakers is installed in your listening room. So, depending on your speaker location in room, close to the wall, away from the wall, we have different scenarios. There may be, of course, something about you that I don't know. For example, that your speaker really are up in the trees, but for the majority, this will not be the case. The frequency increase, the size of the baffle becomes significant, and the spherical radiation pattern no longer applies. This is also partly to do with the loudspeaker drivers themselves. As the frequency increases, typical corner drivers become more and more directional. Anyway, this occurs as the dimension of the cone becomes significant with respect to the wavelengths. One more important sentence. While many people will claim that baffle step equalization is essential, that's not always the case. With the speakers that are against or close to the wall, there will be other reinforcements and cancellations that often have far greater effect than the baffle step. If the system is active, electronic crossover, and has a bass to mid-range crossover at the same frequency as the baffle step, it's just a matter of adjusting the bass level a tad higher. For example, if the baffle is 300 millimeters wide and the crossover frequency is around 380 Hz, that's perfect match. Okay, this was from the theory. This is how it looks in a very large room. When you put it in the middle, you are losing 6 decibels on the bass, yeah, and 100 Hz is where the bass is, and you have a flat bass. And this is ideal in a theory. In a practice, you have a little bit more complex set, but most important for your case is calculate your crossover frequency. Here is excellent formula. The first one is for those who live in meters and centimeters and millimeters, and the second one is for those who lives in feet, inches, and miles. Yeah. I'm living in Europe, so I have meters, centimeters, and millimeters. And I have a speaker, and I have exactly a speaker with 0.3 meter wide baffle, and I should set my crossover at 380 Hz to get adjustments for any listening scenario. Coming back to settings, let's take one channel, and the first what you should do, you should set up one channel. Step 1, we set our lower crossover point between woofer and mid-range to 380. It's somewhere here. It's not that critical. Don't worry about that. And for the tweeter, here you have a little bit more space to play. It also depends on your tweeter type. If the tweeter can go lower, you can set it even at 2.4 kilohertz. It depends on your tweeter type. If your tweeter is about 1 inch, then you can go lower. If your tweeter, and if your mid-range is about 6 inch, then it's better to go lower. But if your mid-range is about 4 inch, then 3.5 kilohertz is a good option where to put it. And in that case, practically majority of soundstage will be defined by your mid-range. And if you have very good mid-range, then you probably have a good mid-range, good soundstage. Next step is start with a mid-range, and mid-range is our hero. Everything will be balanced to the mid-range, and I found out that the best way is set a mid-range about minus 4 decibels, somewhere here, or even here. I think I set it even here. And now it's time to adjust our sonic balance. This is most important. And what we should do, we should take your headphones, listen to the music, and first we roughly put the bass also somewhere here, and tweeter somewhere here. But in reality, what does it mean? In reality, there's a sensitivity differences between mid-range and tweeter. Sometimes mid-range could be far more sensitive and tweeter not so sensitive, sometimes in opposite. That means those adjustments will not be equal. And then listening to your room and listening to your headphones, you try to set up the best sonic balance closest possible to the headphones. Typically, if you have a large speakers, your bass will be richer in a room than in headphones. And this is correct settings. But your sonic balance between instruments, between everything, should be done in a right way. For that purpose, I recommend to take some good recording. And one of the sorts of good recordings is YouTube. Nevertheless, there are compressed signals, but like NRB music male voices. For example, this is a good. This is good. Good recording with a good soundstage, with a rich male voice, and this rich male voice is going down to your first crossover point, and when you're crossing it correct, it will sound right. If it's not sonically balanced, then it kind of has a difference, and using this voice you can set a sonic balance. You don't you shouldn't set a sonic balance based on the drums, on those tidge. It's not important because you have too much room influence here. But sonic balance on a male voice is critical. This also reflects to many instruments, for a jazz, for this big violin, for a cello, for a bass guitar, for many things. Yeah. So I found out that as NBR music has very good recordings, and don't worry that it is compressed. The key is that studio source is very well mastered, and those are incredibly well mastered. And I think the master is even high bitrate kind of music. Of course, here in YouTube it is compressed, but it is good for adjustments. And of course, those who have a Spotify and renting some music services, there are a very good audiophile discs recording with the latest technology, super precise. You them find, but one of probably criteria for lower sonic balance adjustments that you have a low spectrum male voice. Once we did that sonic adjustment, and your speaker should be placed in origin what you will use it. Now it's time to adjust another speaker. Since first one is sonically adjusted, it is perfectly adjusted. Now we need to do the soundstage and the balance adjustments. And what we do, we start with a mid-range, but we unplug high and low, and plug only mid-range in. So this channel is already adjusted, and carefully listening the same recording, we will adjust mid-range until our voice is perfectly in center, it's perfectly balanced. Your stereo is equal for both sides, and of course here we put a zero at a zero. Both channels here are balanced. Only then we do that. It is very important, and it may happen that there is a sensitivity difference between one channel and one speaker and another speaker, mid-range speaker. What you have, it could be 2 up to 3 decibels for a worst case scenario. For a good manufacturers it is lower, so don't be afraid that they will not match here on regulations. Your hearing is a main which should be taken in consideration. When you did it for a mid-range, you do it for a high, so unplug mid-range and plug high frequencies in, and adjust again for a high until you get also perfect soundstage and they are perfectly balanced. The soundstage, of course, for a high frequencies will not be that good as for mid frequencies, but anyway, it's playing a critical role on a lower spectrum, because we can hear soundstage up to 5 kilohertz, and we are crossing at 3.5 kilohertz. And the last one, less critical, so we unplug high and mids and put a low in a balance about the feelings. At low frequencies we don't hear soundstage practically at all. I think the soundstage what we hear is down to 500 hertz, and below 500 hertz we don't hear. The wavelength is too long. But anyway, put it together and then you are done. And in that case, when you do all those adjustments, you will have a sonically balanced performance. You will have precise soundstage, and then you can enjoy your music listening. Now, little bit about what else you can do with an active crossover. For example, here is a brilliant, very expensive loudspeaker from Bowers and Wilkins, I think. Yeah, Bowers and Wilkins, 804 G4, anachronic response on a mid-range axis. And you can see they do a little cheating, because for human it's kind of very attractive, or it's attractive. Then you have this little smiley face, accented bass, and little bit on a brightness somewhere 1000 to about 4 to 10 kilohertz. It's somehow set to sound a bit brighter. If you like, you can do it. It's also by choosing crossover frequencies. For example, if you choose a just crossover frequency at 3.5 kilohertz, you can add a little bit later on according your taste, and make it sound a bit brighter. Yeah, if you like. This is about the taste. Then is modern loudspeaker measurements. There are a lot of measurements, but they somehow simulate with a modern software also room response if you put it different type of the rooms. And then the crossover is sit a little bit different. You can see many measurements on axis, listening window, early reflections. We already talked about early reflections. Those are summing to the main signal, acoustic power average, early reflections directivity index, and acoustic power average directivity index. They get a flat response when anachronic chamber settings are different. Anachronic chamber settings are like that, and then you get from the room those additional frequencies, and then it sounds flat and neutral. But I find out that with simple way that you're listening headphones, what is insulated from the room, and listening speakers in room, you can achieve very good result, very good result. And then you can play a little bit. If your bass is boomy, you a little bit reduce it. And if you need a brighter signal, then you add, you work with a crossover frequency and fine tune until you really like that pattern for your how you listen and how it sounds. You shouldn't be just very strict on the measurements. And I took one example, usage scenario example. I took a garage speaker example. As I mentioned, we have high flexibility of this device. We can use it as a three-way speaker. We can use that amplifier set as a very good home cinema, but also we can give a second life to garage speakers, and for a sandwich price get outstanding sounding system. And let's look on eBay what is available for sales, but probably in your local country, in your local city, there are some kind of a magazine or electronic place where people are selling old equipment, and then you can buy something where that large woofer is okay. You can replace with a modern components, mid-range and tweeter, and then it will sound so good, so good. So what we have on the three-way speakers on eBay are selling some Kickstarter monitors, and this seems for me kind of attractive. There's something on Technics, also could be a good candidate for experiments. Now those are always bad. Bookshelf not, probably you need a higher. Oh, they're also good candidate for experiments. Hard to say. I don't trust that design. It's not, maybe not. Oh, GVC, known brand, and probably it's also a good candidate. Okay, for a couple of hundreds you can buy pairs of them. If it's nearby, then shipping costs are neglectable. Okay, GBL always costs. This is kind of popular brand. And on popular model, some people, it's always cost more, but you can do experiments with a different type. Actually, pretty reasonable offerings for nice experiments. Yeah, even this. There is different type of speakers. But okay, you can replace one or another, or make the mid-range make really great, and then the rest of that use as it is. Okay, once you have so much flexibility with a crossover, and your crossover will be far better than it's originally, I like this one. Let's look closer. It even has additional stands. For me, it seems good. In very good condition. Kick-seater monitor 100 German-made three-way speaker, and you can see that those speaker protection surges are in. Seems that tweeter surge has been replaced. It was sometime I had a problem for that. Good candidate. And look, if you replace that input with some adapter plate and 8-pole speak-on connector, you can make those speakers passive, and I think a woofer here is excellent and well made. So you can make from those from this speaker exceptionally good sounding device. I have no clue are those good loudspeakers or not. in case those loudspeakers are good. I think the biggest problem is the tweeter for those. The mid-range somehow maybe even a good one. But with so long time, I think it's a 20 years old speaker, I don't know about details how it is made. This ferrofluid probably has gone. And today we have for about $50 exceptionally good mid-ranges, and then you can improve it. But it may happen that it is good mid-range. Even in a moment when you put it on an active crossover, it will shine. Yeah. I think that linearity of all old mid-range speakers was kind of so-so. It may happen that in garage you already has some of them with a bad mid-ranges and a bad tweeter, but a good woofer. And you can do the tests about. And good luck with your project.